We're going to do a reference chart review to help you with your EOC tomorrow. So we're going to start in this section right here for properties of exponents. Students often think that this is one of the hardest areas, but if you use your reference chart, it can help quite a bit, especially if you don't remember if you add or subtract or multiply or whatever with the exponents. So starting with product of powers. Anytime you have a, this is the exact same thing as having a to the 1. And that's going to help in situations like this where it's being combined in some other fashion. If you have a to the 0, that is equal to the number 1. Anything to the 0 is equal to 1. 5 to the 0, 20 to the 0, a million to the 0, all of that equals 1. And a lot of that has to do with the quotient of powers rule, which we'll get to here in just a second. Then you have product of powers. Product of powers is when your bases are being multiplied. The exponents act as though they're telling you how many of that number you have. So if you have 5 A's and 4 A's, you would have 9 A's, which is why you add the exponents in this situation. You don't add the bases because the type of base didn't change, just the amount of that base changed. Quotient of powers, remember that anytime you have something on top of another something, they equal out to 1. You guys are used to just like crossing them out like this. So in that case, that's just like subtracting. And then this also on this side shows you exactly what the operation is. Remember, the base does not change, only the exponent does. I like to tell kids to identify if you have more on top or on bottom, because after you eliminate whichever one you have more of, that's where they're going to be left. So oftentimes this is a really great test strategy, is to focus on whether or not you have more on top or more on bottom. Power of a power. This one is commonly mistaken, especially if you have a base in front of a letter. But power to a power, you're basically distributing that power to the exponent. Not to the base, but to the exponent. So we like to say distribute, and every time you distribute, you multiply. Rational exponent, this is just a rearrangement. And so this one, you definitely want to peek at your formula chart whenever you're looking to see how to change this to square root. And that's when you have a fractional exponent. Negative exponents, you don't want to do any products, quotients, until you flip and then make it positive. So if you notice here, a to the negative n ended up on bottom, because if it's not a fraction, it's on top. So a to the negative n ended up on bottom as a positive. That's what I mean by flip it and make it positive. So I want to go back up here to power of a power. If you have 5a to the second and then to the third, this is where we often see mistakes made. That is the same thing as 5 to the 1. So you would do 1 times 3, not 5 times 3, but 5 to the 1 times 3. And then your a, you would also multiply the exponent on. So I'm distributing that exponent to the inside, but only to the exponents, not to the base. So when you have a number base, please understand that that's often where people mess up. So the steps to solving, you would distribute, that's your first step. And then you would move your negatives. And then you multiply across. Oh, I'm sorry, you can't see that. And then your last step is to simplify. So you would be doing the distribution. I like to say get rid of the parentheses first. And then move any of your negatives, flip them. That way you can multiply straight across. Top times top, bottom times bottom. And then you can simplify. So simplify being product of powers, quotient of powers, all of those. The number one mistake people make, and I'm going to put this over here, is in this up here. So when you have 5a to the second to the third, the number one mistake people do is 5 times 3. And they do this part right, but they do this part wrong. So that is definitely a number one mistake.